In this video, we're going to be talking about composite functions. Just before we do that though, I want to say a quick word as an aside. Okay, so we've looked at two ways of combining functions so far, depending on whether you've watched those videos or not, and that is adding, subtracting, multiplying, and dividing, right? I'm just going to write x/divide, the divide symbol, okay? And we've looked at hybrid functions, okay? Don't worry if you haven't watched those videos yet, because composite functions are completely different. So I just want to relate them back to this because they're all sort of involved in the same topic, which is making new functions by combining existing functions in particular ways. Okay, composite functions. A composite function is basically a function within a function, right? Within a function. Functionception. So it's a function within a function. Okay, the notation that you use is, there's two notations that you could see. One is, for example, I could say h of x, which I'm going to call my new function, is f of g of x. Okay, does that make sense? We've got one function inside another function, right? This function is inside, and the f function is outside, right? Outside. Okay, that's one way you could write this notationally. Another way is saying that h of x is f o g of x. It's not fog, it's just f o g, right? This o stands for off, right? So just like if you were sort of pronouncing this, you would say h of x. If you're pronouncing this, you would say f of g of x. That's why you have f of g of x there, right? I prefer to use this one this notation, just because it, to me, it's more clear what's going on, but you could see both of them in textbooks. Okay, we're just going to go through some examples here. One really important thing to know how to do is to find the domain of a composite function, right? But because that's it's not too complicated, but it's going to take more time than I have in this video, so I'll make another video about it. What I'm going to do here is give you an example of a composite function. For example, let's say we have, f of x is, x squared, right? And g of x is equal to sine of x. I'm going to make a hybrid function, which is going to be, I'm gonna put the f inside the g. So g of f of x. What that's going to turn out is it's going to be sine of x squared. Okay, that's what that new function is. Okay, now you can treat it just like you would any other function, right? If you want to find, for example, let's say you're asked to find h of 2. Well, just sub that in, right? Sub in sine of 2 squared, which is equal to sine of 4, which I don't know off the top of my head, but it will be, if you're talking about degrees, it will be some decimal. Same with radians. You could do h of root 30, which is sine of root 30 squared, which will become sine of 30, and if that's in degrees, that will be a half. Okay, so you can do all your normal operations as usual, and I'll just give you one more example, which is, we'll have f of x is equal to x squared plus 2x minus x cubed. So this is a cubic, and we'll have g of x is equal to x to the power 4. Okay, I'm gonna put the g inside the f. Okay, h of x is going to be equal to f of g of x. Okay, it would probably be better if I color coded this. Okay, I'm just gonna write this out again. So f of x, x squared plus 2x minus x cubed, g of x is equal to x to the power 4. Okay, and our new function is h of x. Okay, that's equal to f of g of x, right? So f of g of x. And this, you might already see how I can put that in there, but just I just want to make it clear that to sort of, to find out what h of x is in its simplest form, what you would do is get g of x, and wherever there is an x in f of x, you sub in g of x, right? So what that means is, so I'm going to write down the template for f of x. It's something squared plus, so f of something is something squared plus 2 something minus something cubed. And the something that we're putting in is g of x, okay? So g of x, g of x, g of x, okay? And then that just becomes x to the power 4 everywhere, right? X to the power 4. So if I were to write that, that would be x to the power 4 squared plus 2x to the power 4 minus x to the power 4 cubed. And of course, if we expand all that out, that becomes x to the power 8 plus 2x to the power 4 minus x to the power 12. Okay, so in this video, I just wanted to show you sort of how, so the process of subbing, subbing one function into the other function, because some students do find that a little bit challenging just because they haven't seen it before. But now that you've seen it, hopefully you have a better understanding of how to do that.